Now let's see how another member of the RL78 microcontroller family, the general-purpose RL78G11 with rich analog features, can be used to create a low-cost battery-operated water quality tester. What are total dissolved solids, otherwise known as TDS? It is the total amount of mobile ions and suspended solids, including minerals, salts, metals, and compounds dissolved in a given volume of water. Examples of dissolved solids are shown in the table here. It is often expressed in units of milligrams per liter or possibly in parts per million. How is TDS measured? It's measured by the electrical conductivity of water. Pure water has almost zero conductivity, as evidenced by measuring the resistance of distilled water. Conductivity is about 100 times the total cations or anions expressed as equivalents, and TDS is calculated by converting the EC by a factor of 0.5 to 1 times the electrical conductivity. In this quick solution design example, there is no requirement for the LCD panel to remain constantly driven. So we decided to choose a low-cost 20-pin RL78G11 with rich analog features consisting of 10-bit A to D, a DAC channel, 2 comparators, and programmable gain amplifier. The 3-digit display is driven by an external 8-bit shift register for LCD segments in conjunction with 3 common lines implemented with the MCU's general-purpose I/O lines. This configuration provides up to 24 total LCD segments drive. The LCD panel displays TDS in 0 to 999 part per million units and ambient temperature level as well. The total dissolved solids level is measured by a combination of 2 I/O pins with a resistor network and 1 ADC analog input. Here is the total dissolved solids probe hardware implementation. Normally the MCU is in stop standby mode, drawing about 0.35 micrograms typical with no internal clocks running. Turning on the internal 15 kHz low speed clock and enabling 2 cascaded channels of 8-bit timer only adds 0.23 micrograms higher current drain. Then using the long-term repetitive wake-up interrupt could be implemented, ranging from milliseconds to about 10 minutes. When the MCU is woken up by any key press, the MCU draws 1.1 milliamp typical at 8 MHz operation. ADC conversions would only add 0.5 milliamp typical current, but happen quickly, so the added average current drain is negligible. After the TDS reading is obtained, the MCU can switch over to low-power MCU mode at 1 MHz, alternating between CPU run mode at 124 microamps current drain, but mostly residing in CPU halt mode in low-power 1 MHz mode, drawing only 28 microamps. Therefore, for one TDS reading and keeping the LCD panel driven for 2 minutes before timing out and the CPU returning to stop standby mode, the average current might only be 35 to 40 microamps.